In this video, we will talk about the file system operation. Operating system implement system calls for processes to request access to the file content. Here we need some data structures to implement these file system operations. Several on-stage and in-memory structures are used to implement a file system. Here we will briefly introduce or briefly describe some on-storage data structures and in-memory data structures used in the file system. The on-storage data structures. On storage, the file system may contain information about how to boot an operating system stored there, and the total number of blocks, the number and location of free blocks, the directory structure, and individual files. Now we will describe this briefly. First, on-storage data structure is a boot control block. So we have the boot control block data structure for each volume. This boot control block contains information needed by the computer system to boot operating system from that volume, if the operating system is stored on that volume. The next one is a volume control block. Each volume has a volume control block. It contains volume details, including the total number of blocks in this volume and the size of blocks, the number of free blocks, and the free block pointers. In the Unix file system, the volume control block is called the super block. In the NTFS file system, the volume control block is called the master file table. And the next on-storage data structure is the directory structure. Each file system has a directory structure. We use this directory structure to organize the files in this file system. In the Unix file system, it includes file name and associated inode numbers. In NTFS, this file system, it is stored in the master file table. The directory structure is stored on the storage. This data structure is stored on the storage. And we also have the per file control block. Each file has a file control block. The file control block contains many detailed information about the file. File name, the file descriptor, file size, the location of the file, timestamp, permission, the owner information, etc. So the file control block is a very important data structure in the file system. The file control block is also stored on the storage devices. It's a storage structure. For the in-memory information is used for both file system management and performance improvement via caching. The data are loaded at mount time, updated during the file system operations, and discarded at dismount. So the several types of structure may be included. Here we have the in-memory mount table. It contains the information about each mounted volume. In-memory directory structure cache holds the recently accessed directory information. And here we also have the system-wide open file table. This table contains a copy of file control block of each open file and other information. The entire computer system has one system-wide open file table. And we also have the per process open file table. Each process has an open file table. It contains pointers to appropriate entries in the system-wide open file table, as well as other information for all the files that process has opened. Now, each process has a per process open file table. When a process opens a file, the file system will add an entry in this per process open file table. And now let's take a look at an example how to use this data structures, the on storage and in memory data structures. First, to create a new file. To create a new file, the file system needs to allocate a new file control block. We know the file control block is on the secondary storage. Okay, the file system allocates the space for a new file control block on the secondary storage. And then the file system read the directory structure into the memory. Okay, now it doesn't read the entire directory structure into the memory. It reads the appropriate directory into memory. Update this part of directory. So read this block of directory structure into the main memory, because now we create a new file. We need to add this new file in the directory structure. Add this new file at the appropriate position or the appropriate location in the directory structure. So we read this part of directory structure in the memory. Add this new file, add this entry in the directory structure, and then write back this block back to the directory structure. And also the directory structure, this entry pointed to the file control block of this new file. So this is a create operation. Now, after we create a file, we can use this file for input output. So now before we use this file, we need to open this file. We open a file. The open call pass a file name to the file system. We give the file name. That means the process need to open this file. Now this system call first search the system-wide open file table to see if other processes already open this file. If the other processes already open this file, now we just add an entry in the per process open file table. Because this process open this file, so we add an entry in this process open file table. And then this entry pointed to the corresponding entry in the system-wide open file table. Now for each entry in the system-wide open file table, there is a count. There is a counter. We'll see the counter. This open counter. Now, if now I'm trying to open the file main.cpp. Now I already have two processes. This file is already opened and accessed by other two processes. Now the open count is 2. Now this file is already open, is already in the system-wide open file table. Now the third process open it. So this count is incremented from 2 to 3. Now, the current process add an entry in the per process open table, and the pointer pointed to this entry in the system-wide open file table. And we also increment the open count. That means now 3 processes open this file. 3 processes open this file. Now, if the process want to open the file main.cpp, but the main.cpp, this file is not in the system-wide open file. That means no process open this file. So now the file system need to add entry. Now the file system need to add entry in the system-wide open file table. Means now we have a process open this file main.cpp. We add this entry in this system-wide open file. And then we copy the file control block to this entry. Copy the entire file control block in this entry. And now at the same time, we add an entry at the per process open file table and add a pointer pointed to the corresponding entry in the system-wide open file table. Okay. Now when a process close a file, this is the open file. When a process complete the read and write, close a file. A process close a file, it will remove the entry from the per process open file. Now we close this file, we remove this entry from the per process open file table, and then check the open count in the system-wide open file table. If the open count is 0, means when this process close this file and now no process open this file, this file is not opened by other processes. So no other processes are trying to access this file. Now the open count is 0. When the open count is 0, the file system will remove this entry from the system-wide open file table. Okay. Now this is a create operation, open operation, and close operation. How this operation, the file system operation use on storage data structure and in memory data structure. Here the most important data structure are this. The system-wide open file table, per process open file table, and the structure, the directory structure. These 3 data structure are very important. Okay, this video will stop here.